All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations that are based off of the Mozilla Developer Network Learn Web Development series. I'm in the JavaScript section and we're talking client-side storage. All right, and we just went over an example of web storage. And now we're going to talk about indexed DB storage. All right, as it says, it's sometimes abbreviated IDB. Notice it's a complete database system available in the browser in which you can store fairly complex related data. And it says it's not limited to simple types like strings or numbers that we just had with the web storage. You can store videos, images, and a lot of other stuff. It comes at a cost. It's more complex to use than web storage. So in this section, it says we will really only scratch the surface of what it's capable of, but it's enough to get us started. All right. So it says here we'll run through an example that allows you to store notes in the browser and delete them whenever you'd like. All right. Getting you to build it up for yourself and explaining the most fundamental parts as we go along. So this is what it looks like. So in a way, at least, it's a to-do list. Note, app, whatever you want to call it. So you can come in here, all right, and you can delete an existing note, or you can come down here, add a note title and note text, and create a new note to put it in here. All right. So as it says, each note has a title, some body text, and each is individually editable. The JavaScript code we'll go through has detailed comments to help you understand what's going on. This is a terrific example. All right. So first thing I want to do is I want to go out to the files that I had before for my web storage, and I'm going to get rid of them. Then I'm going to go open up my web storage, which is right here. And that was my greeting, etc. So I'm going to open up, I'm going to create a thing that says web storage. I could just create another folder, but I'm not going to. And I'm going to come in here with this one, and I'm going to call it indexed DB. All right, and that's where I want to save everything. So we are told to come in here then, and first grab the index.html file. Okay. Yeah. So there's that one. And again, this will be index.html. Oops. There's that. Next, we are told to grab the style.css file. And we will put that in there as style.css. All right. And next, we are told to put in the index.start.js file, which is just giving us some constants. So this is index-start.js. Now, that's going to eventually be index.js, so that's what I'm going to save it as. All right, so I've got the three files all put in. Says have a look at the file. The HTML is simple. A website with a header and a footer as well as main content, place to display notes. So it's basically set everything up. Rename your file to index. I already did that. But before we even set up the database, let's quickly run this just to verify that indeed, that it is running. And there it is. So basically all it is it's basically sets everything up for us. I blew it up to what? Let's blow it up to about 150% so you can see it really well. All right, get rid of that, get rid of that. All right, let's keep going then. All right, let's have a look at what we have to do in the first place to actually set up a database. Below the constant declarations, add the following lines. Now, this is just creating a variable that's going to be used later to store the object that represents the database. DB is a common name, but you could call it anything you wanted. It really and truly would not matter. So we've got that. Again, as you can see, they're doing a nice job here of commenting as they're going along. Next, add the following to the bottom of the code. All right, so we're basically setting up a function to run when the onload method is called. It says we will write all of our subsequent code inside of the window.onload event handler, called when the Windows load event fires to make sure we don't try to use the functionality before the app has completely finished loading, because otherwise it would fail, as it says. Inside this, let's start adding some information. All right, so open the database, which we are calling NotesDB. It is created if it doesn't already exist. So it says this line creates the request to open version 1 of the database, known as notes_db. If this doesn't already exist, it will be created for you by subsequent code. You will see this request pattern used very often throughout IndexedDB. Database operations take time. Now, earlier we talked a lot about synchronous code and asynchronous code. Now, with what we're doing, you're really not going to be able to truly appreciate this, because to really understand when they talk about some of this stuff taking time, if you've got a database that you open that has 1 million records in it, of course it's going to take more time to work through, go through, etc., than one that has 2 or 3 records in it. All right. It says you don't want to hang up the browser while you're waiting for results, so database operations are done asynchronously, meaning that rather than happening immediately, they will happen at some point in the future, and you'll get notified when they're done. To handle this in IndexedDB, we create a request object, which, as it says, can be called anything you like. They called it request, so it's obvious what you're using it for. All right. You then use event handlers to run code when the request either completes or if it fails or whatever. So you can do what you want to do based on the results of that. Note, the version number is important if you want to upgrade your database. All right, so in other words, what you're going to see here in just a minute is we're going to set up a table type of structure. But you might decide later that with what we saw right here, maybe we want something new. So in other words, maybe we want to come in here later and not just have a note title and a note text, but maybe have another field in here that's called note create date. So we would add another field here. If that happens, we really should go and update our version from version 1 to version 2. And that's what they're saying right here. All right. So it says now add the following event handlers just below your previous addition. Again, inside of the on event handler. So again, you'll notice here that we have a lot of comments explaining what's going on. One error handler signifies the database did not open successfully, and that's the on error. On success signifies that it did open successfully. So if this runs, of course that wouldn't run, and if this doesn't run, then that should run. All right. Store the opened database in the DB object. As it says, this is used a lot below. All right. Run the display data function to show the notes that are already in the database. And of course, when you do this the first time, so if we put this in, all right, if we put it in like that, now we put it in, and if we go back to our program and refresh, it doesn't look any different because we don't have any notes that we've put in yet. I don't even know if we've got that stuff put in here yet, but let's see. Let's put in here mow the lawn. How about mow? Grass needs cutting. Now, I don't know if we've got it set up yet. No, we don't even have it set up yet. So right now, it's not doing anything. Totally fine. We're going to fix this in a minute. So as it says, the on error will run the system come back saying that that the request has failed, which allows you to respond to your example. All we're doing is doing a console log. All right. The request.onSuccess, on the other hand, will run if the request returns successfully, meaning the database was successfully opened. As it says here in this case, an object representing the opened database becomes available using the request.result property. This will allow us to manipulate our database. We store this in the DB variable that we created earlier, and we'll use it later on in the program. We also run a custom function called display data, which should display all of our data in an unordered list. It says we run it now so that the notes already in the database are displayed as soon as the page loads. You'll see this defined later on. Finally, for this section, as mentioned, we'll probably add the most important event handler for setting up the database. Request.onUpgrade needed. As it says here, this handler runs if the database has not already been set up, or if the database is open with a bigger version number than what's out there existing. Add the following code below your previous event handler. All right. Now, what they say here, and it may not totally make a lot of sense to you, but basically what it's saying is we're defining the schema of our database. Now, I don't want to get too much into this because I don't want to confuse anyone. But in virtually every kind of database system you use, you will typically have some sort of schema set up. The schema will define what the database looks like. In other words, I'm going to show you this very quickly here because I'm already at 12 minutes and I might almost finish it right here. But usually when I start talking databases to people, this is what I say. All right, I'm going to go from smallest to largest. So you got a character. All right, you all know what a character is. There's nothing big there. And I'm going to say any keyboard character. All right, and then from there you'll have a field. And what's that? That is one or more related characters. So I could have a field called first name. And I could set it up so that would be 1 to 25 characters. A field could be as small as 1 character because maybe I've got a field and that field is called middle initial. And that could be just a single character. So the character is what you key in. You put one or more of these related characters together and you get a field. All right. Now, you put one or more related fields together, and you've got what? You've got a record. So in other words, let's say that I set something up where there was a first name, there was a middle initial, there was a last name, there was an address, a city, a state, and a zip code. All right, so each one of these things that we keyed in, including the blank spaces, are characters. This is a field, so that's 1 field, 2 fields, 3 fields, 4 fields, 5 fields, 6 fields, 7 fields. And all that stuff put together is information about me. All right, so that's fine. Then you get a table, if I can spell. And with that table, that is 1 or more related records. So let's say that I put in Mr. Corrigan in here also. Whoops, I didn't want to do it like that. And I don't know what Mr. Corrigan's middle initial is, so I'm just going to make one up. All right, we'll move this over so it lines up. So now I've got a table with 2 different records in it. I can add yet another record into it. All right, so I can put in Mr. Growherring. I don't know what Chad's middle initial is. We'll say G. All right, so now we would have a table with 3 records in it. All right, finally we get to the last part here, which is a database. And a database is 1 or more related tables. So if I had another database in here that maybe said something like this, 1, information technology, 2, electronics, 3, I don't know, business systems, and I think BSAM is business systems and manufacturing. I don't know. Now I'm going to add something here quickly just so you see it. All right, and I'm going to put in here a 1, a 1, and a 1. And I don't know the names of most of the people who work here, but I'm just going to put one in. So I'm going to put in here Mary R. Smith. We're going to keep the same address. I'm going to keep everything in here. But I'm going to imagine right now that Ms. Smith works in the electronics department. And we'll put one more in here. And we'll put in here, I don't know, Kate S. Frazier. And let's say that Ms. Frazier works in the business systems and manufacturing area. So you can hopefully start to see now if somebody says here, hey, I want a listing of everybody who works in information technology, that one that's there is going to basically allow us to go into the one that's here and get all those people. All right. Now that was very quick, but typically when you set this up, if I was setting up the schema for this, I would do something like this. I would have like first name, and it would say something, it depends on the language we're using, but I'd say something like varchar 25, which means variable length of 25. And then I might say middle init, and let's say char 1, because that's a single character. And then we'd have last name, and we'd have varchar, again of 25, address, and that would be a varchar maybe of 50. We might need more for that. City, we'd make a varchar, let's say again of 20, not a varchar, of 25. State, we'd make that a char of 2. And zip, which we'd probably make a varchar because we probably wouldn't make it a numeric field. I'll get into that conversation another time. We make that 10. So if we wanted to put the dash with the 4 digits, we could do that. And then let's put in here department number. And we'll make that, well, we might have more than 10 departments. So let's make that a varchar of 2. 99 departments should be plenty. So this would be a schema for this. And there's other stuff we might add here. For instance, we might put here, we might have here a 1, here a 2, here a 3, here a 4, here a 5. And what we put in here first then would be ID. And don't worry about what that means. And we'd put in here auto, something like this. Increment, all right, primary key. All right, which just means this is a special field that uniquely identifies this record. All right, so that's how we would set up that one. Let me copy these down. And then say for this field, for this table, so this table right here, this would be table, let's say, employees. All right. And this down here, so that would be all of this. Then down here, this would, whoops, yeah, I got it. This would be like table departments. All right, I again might have an ID here, which is fine. Okay, and here all we're going to put in here is department name, and we'll make it a varchar of 25. So ideally what you got out of this is these would be the schemas that we'd set up. Now, it depends on the particular type of database management system we're using. Some don't look anything like this. Some would look very much like this. But I'm going to just stop it right now, jump back into here, and I don't know if I put this in or not, so let's double check. So we've got database setup complete, which says to me we probably have it in there. Yes. So this is where we define the schema. That's what I just showed you. The set of columns or fields it contains. Here we first grab a reference to the existing database, all right, which is the request object. This is equivalent to the line db equals request.result. All right, inside the onSuccess handler, but we do need to do this separately here because of the onUpgradeNeeded handler if it's needed. We then use the IDB database, create object store to create a new object store inside this called Notes OS. This is equivalent to a single table that we're putting in here. We've given it the name Notes, which is also specified in auto increment field in here someplace. There it is. All right, with ID. So I showed you that. It didn't look exactly like this, but the ideas are the same. Each new record will automatically be incremented to give it a unique value. That's that ID. All right. We also create two other fields, the title and the body. So with this simple database setup, we can start adding records, which will look like this when we set them up. All right. Now, I'm going to stop right here and continue on with the adding data to the database in the next lecture.